So you might see it written like that. You'll see S used for displacement quite a lot in the next few sections, okay? Especially in the constant acceleration lesson next time. And a curve is an acceleration or a deceleration, as we've just talked about. That's pretty much it for distance time graphs. There's not too much to know. A lot of that you were probably already aware of. So we're going to move on to velocity time graphs now, which tend to be a little bit more complicated, but much more likely to come up in the exam. So here's another example one. So what we have to remember is that each section is actually different to what it would be in a distance time graph. This time, a straight line with the same gradient, is actually an acceleration. And it's actually a constant acceleration. Okay, so a straight line is a constant acceleration because here you can see we're changing from zero velocity to a higher velocity. So if we're increasing our velocity, we must be accelerating. And in contrast to the distance time graph, a flat section means a constant velocity. Okay, we're not stationary this time. We're actually traveling at a constant velocity. We can tell that because if we look here, we're going, this stays at the same velocity, doesn't it? Say this was 10 meters per second, for instance. We would be constantly going at 10 meters per second for this section. So we must be traveling at a constant velocity. We've got acceleration again here, and it's constant acceleration again. But because it's steeper, the rate of acceleration is higher. So this is quite a high acceleration. And this is quite a low acceleration. So this might be, maybe it's 1 meter per second. Maybe this one is 3 meters per second squared. Yeah, they're just made up numbers. I've not measured those. It's just an idea that this is a higher acceleration because it's a steeper line. Constant velocity again up here at the top. And here we have a deceleration. It's a constant deceleration. We can tell that because it's a straight line and it's heading back towards zero velocity. So I'm going from whatever this velocity is, I don't know, maybe call it 20 meters per second, all the way back down to 0 meters per second down here. The line's straight, so it must be a constant deceleration. So lines heading back to the origin does not mean we're moving backwards. It means the velocity is reducing, okay? So unlike distance time graphs where lines, or displacement time graphs where the lines come back towards the origin, that would mean it was moving backwards, but on a velocity time graph, it doesn't. It just means it's actually slowing down. So a summary of that, acceleration is the gradient of the line on the VT graph. So to work out A, we'd measure the change in velocity divided by the change in time. That will give us the rate of acceleration. And a curve is a varying or a non-uniform acceleration. So I didn't show you an example of that, but if we have a curve, an increasing curve like this on a velocity time graph, it means we've got increasing acceleration. So it means I'm accelerating lightly to start with, then that rate of acceleration is increasing. Okay. In contrast, if I had something that just looked like this instead, this would be decreasing acceleration.